Hello, this is Reed Tillery, and in this video we're going to look at using the UTM Grid. UTM stands for Universal Transverse Mercator Grid, and it is a grid based on kilometers that is often used by land navigators. Marine navigators, on the other hand, often use the lat-long grid, and the unit of measurement there is usually the nautical mile. Let's look now at how the UTM grid is formed. What cartographers do is they take the earth, they want to take a section out of it and lay it flat. So what they do is they take the earth and they skin it, you might say, just as if you were skinning an orange. So up here at latitude 84 degrees north, they make this incision, and of course I'm speaking figuratively. They make this incision in the earth, and down here at 80 degrees south latitude they make another incision. You notice it's 84 degrees up north and 80 degrees down south, and then at 180 degrees east-west longitude they make an incision in the earth, and of course that's on the other side of the globe from Greenwich, England. When you make those incisions that we just talked about, of course what you get is a section of peel, you might say, from the earth that looks like this. The top of the peel was the 84 degree north latitude line, the bottom of the peel is the 80 degree south latitude line, and you can see that the peel is split at 180 degrees east-west longitude. So now what we're going to do is to look at that section peeled from the earth and squash it flat into a nice rectangular shape, and the north border of this rectangular shape is formed by the latitude line at 84 degrees north, and the south border of this rectangle is formed by the latitude line at 80 degrees south. The east-west border is formed by the 180 degree longitude line, east-west longitude line, which is of course the international date line on the other side of the earth from Greenwich, England. Now this rectangle, as you can see, is divided into long thin zones, and each one of these zones is depicted by a vertical line there, and there are 60 UTM zones, and they are numbered 1 through 60. Zone number 1 begins on the left side, and zone number 60 ends on the right side. So here we see the outline of a single UTM zone with its northern and southern boundaries indicated. Notice that it is 6 degrees of longitude wide. There are 60 such zones, so 6 degrees per zone times 60 zones equal 360 degrees all the way around the earth. Remember looking at how the section peeled from the round earth was squashed flat into a rectangle? Well, that squashing process distorts slightly each of these zones. This zone here, for instance, which actually follows converging longitude lines, as do all zones, becomes a rectangle with parallel sides. As a point of interest here, let me say a few words about north-south lines on the map. The north-south lines formed by longitude lines are true north lines, true north-south lines, and the north-south lines formed by UTM grid zones are not really true north-south lines, whereas the longitude lines run to true north, the UTM lines run to what's called grid north. Now usually there's not a lot of difference between grid north and true north. It's usually not appreciable, but there is some small difference. Let's look now at how a UTM zone is divided into smaller areas. Here we have a UTM zone that's been squashed flat into that nice rectangular shape, and up here at the top, of course, the zone runs to 84 degrees north latitude, and down here at the bottom it runs to 80 degrees south latitude, and we said the zone is 6 degrees of longitude wide, and the zone is bisected here at the equator. Then running the lengthwise of the zone, in the middle of the zone, is the zone meridian. You see this skinny little line running down here that I'll try to outline. This skinny little line, which is a lot straighter than what I've outlined, is the zone meridian. So between the zone meridian and the east boundary of the zone, and between the zone meridian and the west boundary of the zone, is 3 degrees of longitude, because the zone is 6 degrees of longitude wide. Okay, so now let's look to see how a zone is further divided into quadrants. Here we are at zone 17, and zone 17, as you will recall, is divided by the equator, and it is also divided lengthwise by the zone meridian, which divides the zone into 2 equal halves. In addition, the zone is divided into 20 quadrants. Each quadrant is 6 degrees of longitude wide. Put right here, 6 degrees of longitude wide, and 8 degrees of latitude tall. Now the only difference, or the only exception here, is quadrant X, which is a little different. Quadrant X, instead of being 8 degrees latitude tall, is 12 degrees of latitude tall. The quadrants are lettered, beginning down south with the letter C and ending up north with the letter X. And you'll notice that that the letters I and O are omitted, presumably because they're too close to 1 and 0. And something that's helpful to remember is here just north of the equator is quadrant N. So quadrant N stands for north, north of the equator. So quadrant N is the first quadrant north of the equator. Okay, so now let's zoom in on a particular quadrant. In this case, we'll say quadrant R. So we're in zone 17, and here is quadrant R. So we're going to zoom in on the quadrant R, and we can see that quadrant R, like all quadrants, is divided into individual 100,000 meter squares. So each one of these little squares here is 100,000 meters times 100,000 meters. Okay, so let's look at a bit more here about how UTM grid squares are divided. We said that quadrant 17R here was divided into individual little squares that are 100,000 meters times 100,000 meters. So we're going to take one of those little squares, we're going to zoom in on it, and this 100,000 meter square here is divided into 100 10,000 meter squares. So each of these little squares is 10,000 meters times 10,000 meters. So let's take one of these 10,000 meter squares here, and it is divided into 100 1,000 meter squares. So each of these little squares here is 1,000 meters, or 1 kilometer. So once again, each of these little squares is 1 kilometer square, or 1,000 meters square. Okay, so now we'll look at a 1,000 meter square here and see how it is divided. Each 1,000 meter square is divided into 100 100 meter squares. So each of these little squares is 100 by 100 meters. If we zoom in on one of these little 100 meter squares, it is divided into 100 10 meter squares. So each of these little squares is 10 meters by 10 meters. Then each of these 10 meter squares is divided into 100 1 meter squares. So each of these little squares is 1 square meter. And that is the smallest unit in the UTM grid. Next, let's look at UTM coordinate values and how they're derived. UTM coordinates or each UTM coordinate consists of an easting and a northing. Eastings and northings are false values based on the arbitrary value given at the equator and at the zone meridian. Let's start out by looking at northings. The equator, for purposes of working your way north from the equator, or for purposes of the northern hemisphere, I should say, the equator is assigned a value of 0 meters north. And for each meter you go north of the equator, that value increases by 1. So at 1 meter north of the equator, your northing is 1 meter north. 2 meters north of the equator, your northing is 2 meters north. 3 meters north of the equator, 3 meters north, and so on. And that continues all the way up to latitude 84 degrees north, which is the northern boundary of the UTM grid. And up at 84 degrees north latitude, the northing is 9,334,080 meters north. That means that's exactly how many meters you are north of the equator, 9,334,080 meters north. Now, for purposes of working from the equator south in the southern hemisphere, for these purposes, the equator is assigned a value of 10 million meters north, and the northings decrease as you go south and all the way down to as far north as you can go. And I'm just going to draw a little squiggly line here to show that this is not to scale, and I'll do the same up north here too. The northing value way down here is 1,110,400 meters north. What this means is you at 80 degrees south latitude, where your northing is 1,110,400 meters north, you are 8,889,600 meters south of the equator. Now, something that is an interesting feature of the northings is no matter whether you're in the southern hemisphere or the northern hemisphere, your northing values always increase as you go north. So even way down here at 80 degrees south latitude, your northings are going to increase all the way from a little over 1 million meters north all the way up to 10 million meters north at the equator. Then once you cross the equator, the values are reset to 0, and your northings will increase as you go farther north all the way up to over 9 million. So southern hemisphere, northern hemisphere, it doesn't matter. As you go north, the northings increase, with the exception of when you cross the equator and the values are reset. Okay, now that we've seen how northings are laid out, let's look at eastings. Here is a section of a typical UTM zone, any zone, zone 1 through 60. And you can see here it is divided in lengthwise by the zone meridian, which I am outlining here. The zone meridian, as you also may recall, is assigned an arbitrary value of 500,000 meters east. It's just a nice round number somebody decided to give it. I'm not sure why they chose 500,000 meters, other than it's a nice round number. Now, as you go east, for every meter you go east of the zone meridian, the easting increases by 1. So here, 1 meter east of the zone meridian, the easting is 500,001 meters east. 2 meters east of the zone meridian is 500,000, 2 meters east, and so on, meter by meter, all the way out to the eastern border of the zone, where the easting is 833,360 meters east. On the other hand, as you go west of the zone meridian, the eastings decrease meter by meter as you go 1 meter west. So, for instance, here, 1 meter west of the zone meridian, the easting is 499,999 meters east. 2 meters west of the zone meridian is 499,998 meters east. All the way out here to the western boundary of the zone, where the easting is 166,640 meters east. One thing that I'd like for you to notice about eastings is eastings always increase as you go east in the zone. So you start on the west end of the zone, and as you go east, the eastings are always increasing. Okay, so now let's look at a full UTM coordinate and how it is written. A UTM coordinate describes the southwest corner of a square, and it is written with the easting first and the northing second. In this case, we know that the southwest corner of this particular square, which by the way is located in Florida's Ocala National Forest, is located in Zone 17, Quadrant R, and it is 75,413 meters east of the zone meridian. I'm sorry, 75,413 meters west of the zone meridian, and the reason we know that is because the zone meridian is given an arbitrary value of 500,000 meters east. So since this value is 424,587, that is 75,413 less than 500,000. So if the eastings are less, then they're west of the zone meridian. Then the northing here tells us that the southwest corner of this square is located 3,251,412 meters north of the equator. Several other ways that the UTM coordinate might be written. In a GPS, for instance, you may have the zone and the quadrant, and then the easting may be written here as 7 digits. You notice eastings are only 6 digits, but what they've done is just add a leading 0 to balance, to give 7 digits, to balance it out with the northing, which has 7 digits. Down here is another way it's written. You've got the zone, the quadrant, the easting, and here all they've done is just add the letter E for easting and the northing, and here they've added the N to show it's a northing. Okay, so now let's look at how UTM coordinates are often depicted on topo maps. They're often abbreviated. If we come down here, for instance, let's look at the northing. In this case, here on the topo map, it tells us that this line is 3,250,000 meters north of the equator. And then it just drops off these 3 zeros, and it tells us that this is 3,251,000 meters north of the equator, 3,252,000 meters, 53,000 meters, 54,000 meters. And you notice that the large numbers represent the 10,000 and 1,000 place values. You may have noticed in this video that when I presented eastings and northings, that 2 of the numerals were much larger than the others. And now that mystery, if it was a mystery to you, is cleared up, because you know that these represent the 10,000 and the 1000 place numbers. Okay, we can now see that eastings are abbreviated in a similar manner. For instance, right here is the line 416,000 meters east, and this is 417,000 meters east, 418,000 meters, 19,000 meters, 20,000 meters, etc. So each one of these squares then represents 1 square kilometer, and oftentimes this grid, this 1 square kilometer grid, will be superimposed on your USGS topo maps. Sometimes the older maps don't have this grid superimposed on there, but they do have little tick marks out in the margin, and you have to draw in the grid yourself. When you order a topo map, it's always a good idea to see if you can't get the latest and greatest map which has the UTM grid superimposed on it. Let's look now at how to use abbreviated forms of UTM coordinates. Here is a topo map that has the UTM grid on it, and if we come down here we can see the southwest corner of this map. The easting is 416,000 meters east. This should be an E. 416,000 meters east, and 3,249,000 meters north. So if we look at this number here in the easting, the 4, and this number here in the northing, the 32, those numbers represent the 100,000 meter square. So when you're in the area 4 by 32, you're operating within a 100,000 meter square, which is a pretty big square, 100 meters on 100 kilometers on each side. So oftentimes when you're operating within that square, you don't really have to give these numbers all the time because everybody knows where you are. In this case, we'll say we're in zone 17R, and these are our eastings and our northings. So just to abbreviate, we'll leave off the 4 and we'll leave off the 32, and then we'll just describe the 1,000 meter squares, which are described with the 10,000 and the 1,000 meter placeholder. So for instance, if you're up in this square right here, your address, you might say, is simply 21 by 54. So if somebody calls you on the radio and says, "Where are you?" you'll say, "Well, our coordinates are 21 by 54. And what you mean by that is that we're somewhere in this 1 kilometer square, and the southwest corner of this 1 kilometer square in the UTM system has the address, you might say, of 2154. If you were in this square, your address would be 18 by 54. And so each of these squares is identified, these 1 kilometer square, each of these 1 kilometer squares is identified by its southwest corner. But identifying yourself within a 1 kilometer square is usually not accurate enough. You usually want to identify about where in that square you are. So to do that, let's zero in on a 1 kilometer square, otherwise known as a 1,000 meter square. And this square is identified once again by its southwest corner, which is 20 by 53. Remember, we just leave off the 32 and we just leave off the 4, those numbers that identify the 100,000 meter square. Right now we're just concerned with this 1,000 meter square, which is identified as 20 by 53. So when you say that your coordinates are 20 by 53, once again you're saying we're somewhere in this 1 kilometer square. To be a bit more accurate, what you can do is identify yourself within the particular 100 meter square in which you're located. And since the map grid does not show the 100 meter squares. It only shows the 1,000 meter squares. You just have to kind of look at the 1,000 meter square, and you have to guesstimate where in it you are. So for instance, in your mind's eye, what you would do is to divide the 1,000 meter square into 10 places east and west, and to 10 places north and south. So you say, well, let's start right here, and since we're about here somewhere, looks like we're in at about 3, and we're at about 1. So this coordinate right here would be 2, 0, excuse the writing here, make that a better 2. This little electronic pen's kind of tricky. That would be 203 by 531. So if you had to identify your coordinates, you would say we're at 203 by 531. Let's say that you were up in this square somewhere. Let's identify those coordinates. That would be 204. This point right here is 204. By 537. Here's our 7 out here. So 204 by 537. And when you stated your coordinates that way, using this abbreviated system, you would have identified it yourself as being somewhere within a 100 meter square, with 204 by 537 being the southwest corner of that square. For most land navigation purposes, that's about as accurate as you need to be. If you want to even more accuracy, you can follow this on out and zero in on, let's say, this 204,537 square, and you can break it into 10 square meters, and instead of having a 6-digit coordinate, you would have an 8-digit coordinate, and that would put you in a 10 meter square. Or you can go all the way out to a 1 meter square, in which case you would have a 10-digit coordinate. But for most land navigation purposes, just simply identifying yourself within a 100 meter square is sufficient. The very last thing I want to look at here is the Military Grid Reference System, MGRS. The Military Grid is based on the UTM Grid with just a few changes. In the Military Grid, the 100,000 meter square is labeled with 2 letters, and there's a system for labeling each 100,000 meter square with 2 letters, and the letters are usually stated in the phonetic alphabet. Now, I don't know exactly what the letters would be for this particular coordinates, but I'll just, for right now, for illustration purposes, I'll just make up something. I'll say it's LC, or Lima Charlie. So instead of saying my coordinates, instead of saying my coordinates are 204 by 537, using the military system, once again, we still know we're in zone 17R. I would say my coordinates are Lima Charlie 204537. So they do away with the division in the middle here, and you just have to remember that that 6-digit number is divided after 3 digits, and likewise an 8-digit coordinate, which would identify your location within a 10 meter square, would have 8 numerals here, and it would be divided in the middle after 4 numerals, and a coordinate accurate to 1 square meter would have 10 numerals. But that's the military grid reference system. Most GPSs use that. Actually, I like it. I find it a lot easier, but just wanted to introduce that here. And if you understand the UTM system, you have 90% of the military system down. I hope this video on the UTM grid has been useful to you. For more information on outdoor adventuring and on land navigation, be sure to visit my website at floridaadventuring.com. In the meantime, this is Reed Tillery reminding you that no matter what your situation in life, there's always another adventure.